Have you ever wondered why we're so obsessed with Mars when Venus is right next door? In today's video, we're diving into a question that's puzzled many. Why don't we explore Venus if it's much closer to Earth than Mars? The vastness of space has always sparked our curiosity, and the possibility of discovering new worlds is nothing short of thrilling. From the mystery of Venus' thick clouds to the extreme conditions on its surface, there's so much to explore and understand. Stick around as we uncover the intriguing reasons behind our choices in space exploration. You might be surprised by what we find. Venus vs. Mars. Proximity to Earth. Discuss the relative distances of Venus and Mars from Earth, emphasizing that Venus is closer. When looking at the distances between Earth, Venus, and Mars, it's clear that Venus wins in terms of proximity. On average, Venus is about 41 million kilometers away from Earth, while Mars is about 78 million kilometers. This difference in distance might make you think that Venus would be the obvious choice for exploration. After all, a shorter trip means less time, fuel, and resources. However, the challenges that come with Venus' harsh environment often outweigh the benefits of its closer proximity. So while Venus is indeed closer, the conditions we would face once we got there are far more extreme compared to Mars. Venus' thick atmosphere and surface temperatures hotter than an oven present unique obstacles that make Mars, despite being farther away, a more viable candidate for exploration. Yet, the proximity advantage of Venus does raise interesting questions and possibilities about the future of space travel. Venus' harsh atmosphere takes the concept of extreme to a whole new level. The planet's surface temperature is on average around 475 degrees Celsius, which is high enough to melt lead. These scorching temperatures are a result of a runaway greenhouse effect, where sunlight passes through Venus' thick carbon dioxide-rich atmosphere, gets trapped, and continuously heats the planet. But it's not just the heat that's intimidating. The atmospheric pressure on Venus is about 92 times that of Earth's at sea level, meaning if you stood on Venus, it would feel like being nearly a kilometer underwater on Earth. This immense pressure would crush most spacecraft before they even reach the surface. Then there are the clouds. Venus is enshrouded in thick clouds of sulfuric acid, making its atmosphere not only opaque but also corrosive. These clouds rain sulfuric acid, though it evaporates before reaching the ground due to the extreme heat, creating a hellish environment that is challenging for any exploratory mission. This combination of intense heat, crushing pressure, and toxic atmosphere creates a formidable barrier to exploration. These conditions are far more severe than anything we would encounter on Mars, making it clear why Venus, despite its proximity, remains much less explored. The second practice involves exploring Mars' more favorable conditions for both exploration and potential colonization. Unlike Venus, Mars presents an environment that, while still harsh, is significantly more hospitable to human missions. For starters, Mars has a much lower average surface temperature, ranging from about -60 degrees Celsius to 20 degrees Celsius, depending on the time of day and location. This is cold but not unmanageable, especially compared to the scorching heat of Venus. Moreover, Mars is home to water ice, found both at its polar ice caps and beneath its surface. This crucial resource opens up the possibility of using in situ resource utilization, where water can be extracted and split into hydrogen and oxygen for fuel and breathable air, which is essential for long-term human presence. The Martian atmosphere, although thin, is far less hostile than Venus. Composed mostly of carbon dioxide, it has only about 1% of Earth's atmospheric pressure at sea level, which, while still requiring pressure suits for humans, does not pose the same crushing threat as Venus' immense pressure. Additionally, the presence of a stable surface and less corrosive atmosphere makes building and maintaining habitats and equipment much more feasible. These comparatively milder conditions, combined with the potential for accessing water, make Mars a much more promising candidate for exploration and future colonization. While the journey to Mars is longer than to Venus, the more manageable environment it offers is a key reason why it remains a top choice for space agencies looking toward interplanetary exploration and settlement. Technological challenges on Venus explore the technological hurdles of landing and operating on Venus, such as building materials that can withstand the extreme conditions. The biggest issue faced by engineers when designing technology for Venus is the planet's unforgiving environment. The extreme temperatures, intense atmospheric pressure, and corrosive clouds present challenges that push the limits of current materials and engineering solutions. Traditional spacecraft materials simply cannot survive the 475 degrees Celsius surface temperatures. Most metals would melt and standard electronics would fail. This means that any mission to Venus requires the development of entirely new materials and technologies that can endure these extreme conditions. Finding materials that can withstand such high heat and pressure is no small feat. Special high-temperature alloys and ceramics are being researched, but their development and testing are complex and costly. Moreover, these materials need to maintain their integrity over extended periods, as any exploratory mission would ideally last months or even years. The crushing atmospheric pressure of Venus, 92 times that of Earth, also demands that spacecraft and landers are built like deep-sea submersibles, with reinforced structures to prevent them from being crushed. This adds significant weight and complexity to the design. Additionally, the corrosive nature of Venus sulfuric acid clouds means that any exposed surfaces need to be coated with protective layers, which again adds to the weight and complexity. Another technological hurdle is the need for robust cooling systems to prevent onboard instruments from overheating. These systems would need to operate efficiently in an environment where heat dissipation is incredibly challenging. The power supply for these systems must be reliable and sustainable, considering that solar panels would be less effective under Venus' thick cloud cover. These technological challenges require innovative solutions and advancements in multiple fields of science and engineering. While they make Venus a daunting target for exploration, overcoming these hurdles could lead to groundbreaking advancements in materials science and robotics, with potential applications beyond just space exploration. Past missions to Venus have given us invaluable insights, but they've also highlighted the immense challenges of exploring this hostile planet. The Soviet Venera program stands out as the most ambitious and successful series of missions to Venus. Launched between 1961 and 1984, the Venera missions aimed to gather data about Venus' atmosphere and surface. Venera 7, launched in 1970, achieved a significant milestone by becoming the first spacecraft to transmit data from the surface of another planet. Despite the intense heat and pressure, Venera 7 managed to send back information for 23 minutes before going silent. Subsequent missions like Venera 9 and Venera 13 provided even more detailed data. Venera 9 transmitted the first images of Venus' surface, revealing the rocky, desolate terrain beneath the thick clouds. Venera 13, in 1982, delivered color images and analyzed soil samples, offering a deeper understanding of Venus' composition. However, these missions were not without their failures. Many spacecraft were lost due to the harsh conditions, with some never reaching the surface or failing shortly after landing. Despite these setbacks, the Venera missions confirmed the extreme temperatures and pressures of Venus and the presence of sulfuric acid in its clouds, which have been critical in shaping our current understanding of the planet. These initial forays into Venusian exploration demonstrated the feasibility of landing on Venus, but also underscored the need for more robust technology to withstand its environment. While no mission from any country has returned to Venus' surface since the Venera program, The data collected remains fundamental, inspiring future missions and technological advancements aimed at overcoming the challenges posed by Venus' extreme conditions. Future plans for Venus exploration are thrilling and ambitious, aiming to unravel the mysteries of this intriguing planet. NASA has announced two major missions, Veritas and Da Vinci Plus, both scheduled to launch in the coming decade. Veritas, which stands for Venus Emissivity, Radio Science in SAR, Topography and Spectroscopy, is designed to map the surface of Venus with unprecedented detail. Using synthetic aperture radar, Veritas will create high-resolution, three-dimensional maps of the surface, providing insights into the planet's geology, including its volcanic history and tectonic activity. By examining the surface composition, Veritas aims to determine whether processes like plate tectonics are still active on Venus. This mission will help scientists understand how Venus geology has evolved and why it developed so differently from Earth. Da Vinci Plus, or Deep Atmosphere Venus Investigation of Noble Gases, Chemistry and Imaging Plus, will focus on the atmospheric mysteries of Venus. This mission will send a spherical descent probe through Venus' thick atmosphere, collecting valuable measurements on its way down. It will analyze the chemical composition, temperature, and pressure of the atmosphere, as well as capture high-resolution images of the surface once it emerges from the clouds. This data will help scientists understand the processes driving Venus' runaway greenhouse effect and the history of water on the planet. Additionally, there's growing international interest in Venus. The European Space Agency has the Envision mission planned, which will complement the findings of Veritas by providing detailed radar imaging and atmospheric studies. These upcoming missions reflect a renewed interest in Venus, driven by technological advancements and a deeper understanding of the planet's potential to reveal secrets about habitability and planetary evolution. With these missions on the horizon, our exploration of Venus is set to enter an exciting new phase, promising to expand our knowledge of one of our closest planetary neighbors. The scientific value of Mars versus Venus offers a fascinating comparison of two very different planetary environments and the unique insights each one can provide. When we look at Mars, the scientific objectives often center around the search for past or present life, understanding the planet's climate and geology, and preparing for future human exploration. Mars has many features that are similar to Earth, such as polar ice caps, seasonal weather patterns, and a variety of geological formations like mountains, valleys, and dried-up riverbeds. These features suggest that Mars once had liquid water and possibly habitable conditions in its history. Investigating Martian rocks and soil can uncover clues about the planet's past environment, helping scientists determine whether it ever supported microbial life. Moreover, Mars' relatively moderate conditions make it an ideal natural laboratory for studying the potential for life beyond Earth. The discovery of any form of life on Mars would have profound implications for our understanding of life's ubiquity in the universe. On the other hand, Venus, with its extreme conditions, presents a different but equally compelling set of scientific objectives. Venus' thick atmosphere and runaway greenhouse effect offer valuable lessons about atmospheric dynamics and climate change. Studying Venus helps scientists understand the potential future of Earth's climate, particularly as it relates to the consequences of increased greenhouse gases. Venus' surface, obscured by its dense clouds, hides a hot, rocky landscape with volcanic features. Investigating this surface can yield insights into volcanic activity and tectonics, shedding light on geological processes that might still be active today. Furthermore, Venus has an atmosphere composed of sulfuric acid clouds and dense carbon dioxide, making it a prime candidate for studying atmospheric chemistry and the interplay between a planet's surface and its atmosphere. While Venus may not be a likely candidate for life as we know it, its study is crucial for comparative planetology, helping us understand the diversity of planetary environments within our solar system. Ultimately, both Mars and Venus offer unique scientific opportunities. Mars' relatively hospitable conditions make it an attractive target for the search for past life and understanding habitability, while Venus provides critical data for understanding atmospheric science, climate change, and geological processes under extreme conditions. Each planet holds the potential to answer fundamental questions about our place in the cosmos and the factors that make a planet habitable. Public interest and funding have played a crucial role in prioritizing Mars over Venus when it comes to space exploration. The allure of Mars as a potential second home for humanity is a major driving force behind this focus. Mars captivates the public imagination with its Earth-like qualities. It has a day length similar to ours, seasonal changes, and even polar ice caps. These familiar features make Mars feel like a more achievable destination for human colonization compared to the inhospitable environment of Venus. The idea that Mars could one day host human settlers is both exciting and inspiring, fueling public support for missions to the Red Planet. This enthusiasm translates into funding, as space agencies and private companies recognize the public's fascination with Mars and allocate resources accordingly. The potential for scientific discoveries on Mars, such as finding evidence of past or present life, also captures the public's interest. These discoveries could have profound implications for our understanding of life's existence beyond Earth. This potential for groundbreaking discoveries generates excitement and support, which in turn drives funding decisions. Moreover, the concept of terraforming Mars or modifying its environment to make it habitable for humans adds another layer of intrigue. The notion that we could transform another planet to support human life is a powerful idea that resonates with many people, further boosting public interest and funding for Mars missions. In contrast, Venus, with its extreme conditions, does not evoke the same level of excitement or perceived potential for human habitation. Its scorching temperatures, crushing atmospheric pressure, and corrosive clouds present formidable challenges that make the idea of human colonization seem far less feasible. As a result, Venus does not capture the public's imagination in the same way Mars does, leading to less public support and subsequently less funding for Venus missions. This disparity in public interest significantly influences how resources are allocated within space exploration programs. Space agencies and private entities are more likely to invest in missions that garner public enthusiasm, as this support is crucial for securing the necessary funding and political backing. The public's fascination with Mars and the dream of it becoming a second home for humanity drive these investment decisions, ensuring that Mars remains a priority in space exploration efforts. In summary, the reasons why Mars is preferred over Venus for exploration are multifaceted. While Venus is closer to Earth, its extreme surface temperatures, high atmospheric pressure, and corrosive clouds make it a much more challenging environment for exploration and potential colonization. Mars, on the other hand, offers relatively milder conditions, the presence of water ice, and a less hostile atmosphere, making it a more feasible target for human missions and scientific studies. The technological hurdles of designing equipment that can withstand Venus' harsh environment push the limits of current materials and engineering solutions, whereas Mars presents challenges that are more manageable with existing technology. Historical missions to Venus, like the Soviet Venera program, have provided invaluable insights but also highlighted the immense difficulties of exploring this hostile planet. In contrast, Mars missions have consistently advanced our understanding of the Red Planet and its potential for life. Public interest and funding have also played a crucial role in prioritizing Mars over Venus, driven by the allure of Mars as a potential second home for humanity and the exciting possibility of finding life. However, the future of Venus exploration holds exciting possibilities. Upcoming missions like NASA Veritas and Da Vinci Plus, as well as international efforts, promise to reveal new insights about Venus geology, atmosphere, and climate. These missions could pave the way for groundbreaking advancements in materials science and robotics, potentially unlocking the secrets of one of our closest planetary neighbors. So while Mars currently takes the spotlight, the future may hold a new era of Venus exploration that could transform our understanding of this intriguing planet. If you enjoyed this video and want to stay updated on the latest in space exploration, don't forget to like, subscribe, and hit the notification bell. Thank you for watching and see you next time.